Yesterday we left off with our looking at the quadratic formula. Today, as you do today's lesson, you're going to finish using that quadratic formula to solve, but we're going to be talking about the discriminant. And some of you are wondering, what is the discriminant? You can also look in your book. This is in section 9.6 in your textbook, and you are, yes, assigned to do some problems from your textbook. I put it on the board. I also put it in the subnotes. When we talk about the discriminant, that's the part that, excuse me, that's the part that's underneath that square root symbol. So when we talk about the discriminant, that's the b squared minus 4ac. And that's all we're really talking about for the discriminant if you write that down. If you look at the next page in your notes, as we continued from yesterday, and this is in your blue notes, what you're going to be looking at is how do you decide when a quadratic has solutions. So when you have this b squared minus 4ac and it comes out to be a positive number, anytime that's positive, you're going to actually have two solutions. Okay? What are the two solutions? Well, it all depends, but remember, as you think about taking that quiz today, your two solutions are going to be the 2 points where we are looking at it crossing our x-axis. Okay? Also called the x-intercepts, are two real solutions, or two real roots. When b squared minus 4ac, that means we're only going to have one solution. That one solution is at one point where the quadratic or parabola hits the x-axis. And if b squared minus 4ac happens to be negative, is less than 0, then what we are really looking at is that there are no solutions. And if we think about that with our parabolas, it doesn't cross. So when you do your homework and the problems in the book, what you're really going to be asked to is how many real numbers solutions. So you don't have to solve the whole thing, but I don't want to know what the solution is. First thing we have to do is we're going to need to get our equation in standard form. What does it look like in standard form? That means x squared. In this case, we're going to subtract 6x from both sides. Minus 5 equals 0. Again, you still want to think about what is your a, 1. What is your b? Be careful, it is negative 6. And our c is a negative 5. So if we're trying to find out how many real solutions, we're going to look at the b squared minus 4ac. And this is exactly what you're going to do in your homework when you do this from the textbook as you finish and finishing the back of that worksheet. So as we look at this one, we are looking at b squared, and in this case we would be substituting in negative 6. And we're taking negative 6 squared minus 4 times a, which is 1, and c, which is negative 5. Again, negative 6 squared, that gives us a positive 36. 4 times 1, negative 4 times 1 is negative 4 times negative 5 would be a plus 20. Since this solution happens to be greater than 0, our answer is how many real solutions? Two real number solutions. Okay? You're not asked to tell what they are, you're just asked how many. Okay? So be careful that you're reading that direction carefully. Okay? If we look at this second one and we're asked how many real number solutions, again, it's already in standard quadratic form. So we're going to look at the b squared minus 4ac. As you look at b squared minus 4ac, this time we're going to take negative 3 squared minus 4 times a, which is 2, and c, which is positive 7. That means we're going to have 9 minus. Here we're going to have 8 times 7, which gives us 56. 9 minus 56 is a negative 47, which is negative less than 0. So we're going to have no real number solutions. And that is really all that we are looking at besides finishing solving the quadratic. I know as you're going to be looking at, you're just going to, these are some more. One of the thing is that if you're looking at equations like these, as you look at this next one in your notes, the x squared plus 6x plus 5, we're trying to see how many real number solutions. So the first thing you want to take a look at is, let's rewrite it in standard form. X squared minus 6x plus 5, and that's equal to 0. Now, this is the same equation, so we know already that there were two solutions. Okay? That means if I'm going to graph this, can I figure out right away what is my vertex? Well, we've been kind of working with that for a while. This goes back to the beginning of the chapter. How can I find my vertex? I'm going to take x is equal to negative b divided by 2a. So recognizing that from your quadratic formula. So in this case, we're going to take minus a negative 6, which gives us a positive 6, divided by 2 times 1, which means our vertex has to be, our axis of symmetry is x equals 3, and our vertex is going to be over at 3. And now we need to figure out, plugging 3 back into this original equation, what should we get for our y? And if you plug that in, so plugging in 3 squared, as you look at your equation, 3 squared minus 6 times 3 plus 5, so we're going to have 9 minus 18 plus 5, gives us a negative 4. So our vertex is at 3, negative 4. And if we're approximating that, we might say, oh, it's about right here. And if we look at our two solutions, if we're doing a rough graph, we might have something like this. Could you actually find what those actual solutions are? Yes. This is when you would probably at this point use your quadratic formula. So to find this exact solution, x is equal to negative b plus or minus your square root of b squared minus 4ac divided by the 2a, and you would get that solution. So you're going to, you can try this next one, and as you're looking at it, if we think about that, we already knew we had 2 zero solutions, which means the number of x-intercepts, there are none. And what would our graph look like? Well, this 2 is telling us our graph has to go up, and so our graph is just maybe someplace up like this. We don't know exactly, but that would be a good estimate. As you're finishing that blue notes, the key thing I want you to keep in mind is when do we use each method. So solving our quadratics, there's graphing. You use it when you have a graphing calculator. That'd be the key thing. If not, you're going to look at your square roots. What do I mean by square roots? That means you have no middle x term. That means you only have an x squared maybe equals 25, or x squared is equal to 15. That's easy and quick way to solve by taking your square roots. If you can't use square roots, the next thing you want to be thinking about is to factor. If you can factor it easily, either with your greatest common factor or your 2 parentheses, you want to do that. If you can't do that, the next thing you want to be thinking is complete the squared. Key thing is your x squared has to be 1. So sometimes we have to divide. So yesterday, that question 9 that I was working on, it kind of got mixed up a little. I should have divided everything out by 8 and changed that just a little. And we'll look at that. I'll show that to you later. Quadratic formula is not necessarily the hardest thing to use. I think completing the square sometimes is more difficult. But quadratic formula takes a lot more work than if you could simply factor or find your square roots. So quadratic formula is a little more of a process. So kind of keeping in mind, when do you want to use each one? So as you are looking at these, you might be thinking, all right, which method should I use? You want to be able to tell me the reason why. So make sure you talk about these with your shoulder partners. You're asked to do the same thing as you're solving on the back of that worksheet. So make sure you kind of look through these. Your notes should be filled out. You want to tell me, am I going to use, from your methods listed on the page before in your notes, which method would you use? And then be able to tell me why. Why you think that's the best way to use it. You don't actually have to solve them, you just need to tell me which method you would use. Hope this makes a little more sense. Finish that 9-6 worksheet, and I'll let you know what we're doing for tomorrow.